Welcome. This recording is geared toward helping you complete assignment number 4 for the Essentials of Biostatistics course, so sensitivity to ROC. So what you can see is I've provided an R code file focusing on signal detection methods and two .csv files, and we're going to run through this code and generate a PDF that would be submitted. So the first thing to do, other than downloading these, is to watch this video. I'm just going to open it. I didn't set it up to open in a separate window. That's kind of odd, but anyway, now it will.
Hello, welcome to.
So this is an excellent video. We'll watch it at the beginning of class. You can refer back to it if you need to. I like the way that he takes us through it from the perspective of power and sample size, and then talks about how medical students are trained to understand utilization of power and sample size and the signal detection theory to prepare for the USMLE boards and to get through med school and to get licensed ultimately, such that they know how to use a clinical diagnostic test, which is what we want from our biomarker. The other location is on Learning Modules, not the home page. Here under Regression, Causality, Data Reporting, and Quality. It's not the... I'm sorry. Got the wrong module. All right. What is this doing? I've got it in the off mode here. I better go back to... I may not have it set up so it makes sense for you. Sorry about that. Here, sensitivity and specificity. I'll have to see what it's doing. It's weird like that. Hopefully in the student view you can get to it. Because you'll need to... this is an extra video that you can watch if you'd like. It's a bit longer. It's also excellent. We'll be using this PowerPoint. I have it open. These are two excellent brief articles to help you understand what we're doing. This is an Excel file that you need to download and open. That's the one I have open here. We'll use it during the presentation. And then these are the descriptions of the packages. So you need to load 3 packages. We'll scroll this down. epiR package, ROC plus package, and the ROCR package. You'll need to do that before you run these in R. Let me go to R. I opened it twice by mistake here. Okay, here it is. So I've already got the package open. So you'd open it like that first, and then open your the script, then open this script. I've given my sources at the beginning, so you're going to need epiR first, and then the ROC plus, and then the ROCR. So what we're going to do is go through these a step at a time and generate graphs, and then you'll capture the graphs and the results and paste them into PowerPoint, into Word to generate your PDF. So the sequence in class will be to watch that video and then to go through this slide presentation with these definitions of specificity. Oh, this should be sensitivity here. Specificity, sensitivity, positive predictive value, negative predictive value. And then we look at this contingency table. Then we see it again with a set of numbers. And then we apply the formula and come up with these calculations. And then what we're going to do is go to R and begin running R. So I give you my source here. So you have to have the library epiR. Run that. And then we're going to create a data table called DAT as a matrix with these values, and it's going to have 2 rows and 2 columns. We're creating that contingency box is what we're creating. I'm going to run that, and then we're going to label the column names in DAT as disease positive and disease negative, and then the row names as test positive and test negative. Okay, and then let me just type in DAT up here. Okay, so there's your first thing to copy and paste into Word. You can put in a few blank lines here. You can convert these to tables, whatever. Again, this is just the assignment, so we want to just document that we did it. So there's our contingency box. You might be able to convert that to a table and put lines in there so it would look like the contingency box. That's all right. That's before the formula is applied. Now we run the epi tests, and we see the result here. And so this creates the full box for us. And then we copy this and put it into Word. Okay. If you want to make sense of it for your own records, you can copy the text above it and the source and everything, so that you know what went on there. Then what we're going to do in class is we're going to go back to Word, and we're going to change the values in our table to 117 to 27, 23, and 395. So we're just going to go into our script and change these numbers here, 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 in that same sequence that I just read, rerun this, and then when we copy and paste it into Word, we're just going to start comparing our results of the apparent prevalence, true prevalence, sensitivity, specificity, positive predictive value, and negative predictive value. So we're just going to see what happens when some of those numbers change in the columns and rows. Then simultaneously, in the recorded video, there'll be mention of what happens when prevalence changes as well. So we'll go to this, and we'll have to do a search, I guess, somehow to find my source on this. I really regret that I didn't capture it to give credit, and whoever created this didn't put it into their file. I wish they had, but anyway, this is wonderful. I have no idea how they did these slide bars and stuff. I wish I could do things like this in Excel. Anyway, what we're doing here is we're setting our threshold value to compare the difference between our control, our disease minus, and disease plus, where we know it, right? And we're setting the threshold level for our test to determine whether someone falls into the red category or the blue category. And you can see there's quite a bit of overlap, so you have quite a risk of false positives and false negatives. So the higher we move to the right, the fewer false negative, the more false negatives we're going to get, but the fewer false positives. Fewer blues will fall into this zone over here. But we're going to have more people that are disease plus that are going to be called negative, false negative. And you can watch the effects on the values at the right. So at a prevalence of 23, we see the positive predictive value, negative predictive values change, and as we change our cutoff point, the threshold for saying they fall into red or blue, the classification, and the sensitivity and specificity change as well. So as we increase our threshold value, sensitivity decreases and specificity increases. And as we go in the opposite direction, sensitivity increases and specificity decreases. Right? So the idea is to try to make sense of how many false positives and true positives we are sacrificing or gaining, and the same thing for false negatives and true negatives. Then we can slide this rule over here, which is really cool because our curves, frequency distribution densities adjust as we're changing the prevalence. So as we increase prevalence, watch sensitivity and specificity. All right? And then now watch PPV and NPV. Okay, so that's the purpose for that file. So that helps us to understand what's going on there, and we will have completed use of this PowerPoint presentation. There's 2 sets of data that we'll put through just as an exercise. to see what's going on. So then we can progress through our others. We need to open a file here, PSA2B ROC plus CSV, so you will have downloaded it. I'm going to go and find it in my folder. I should have done this before. Anyway. And sample data sets. Here's this one. So we have our table P that's based upon that, and we need to get the rocplus. And then when we do the first one, we get a bare bones ROC, receiver operator curve, right? So here you can do a file save as. Remember, we like to save them as TIFFs. So you can save it as a TIFF, ROC graph 1. So I'm not going to go through all of these, but of course here in Word we would then insert that picture, find it and insert it. There's a bunch of ugly pictures of me. And then we would have it there. I'm just going to copy as a meta file and excuse me, paste right here into Word. However you want to do it. Remember, the TIFF is the proper way that we've trained ourselves if we were generating reports and stuff like that. And then we're just going to go through these, a simple ROC with threshold values. Okay, so that's showing the threshold values. Notice we're plotting sensitivity versus 1 minus specificity. So those will all be explained in the videos and in class, of course. So we're just going to run through line by line. This shows the 95% confidence intervals. And you'll just continue on through capturing each of these. And so there will be one graph for each time you run one of these lines. We will look at a couple of different types of graphs that will not be the focus. Right now we're just focusing on the ROC, the first one we saw, the sensitivity minus over 1 minus specificity. Then we'll open the other package, excuse me, the other file, and we'll move through all of these. Again, every time you see a plot, you're going to get a plot, and this explains what's going on. There are sources of reading, as I said, the files that are available to you. So this is the test properties 2, likelihood ratios, Bayes formula, and receiver operator characteristic curves. They're very nice short articles, again for training physicians. And this is the first one, sensitivity, specificity, and predictive values. Then these are the descriptions for the epi test, the ROCR, ROC precision recall. That's 2011, and then there's one that's for the February 13th update. So those are the resources for you to gain a better appreciation of the value of these. We've seen some of them in our earlier presentations, recorded webinars and things like that. So once you have completed your Microsoft Word file, of course, we do a save as a PDF and name it as assignment 4 with your name on it and everything. Save it as a PDF. Once you've saved it as a PDF, you go back to the assignment as you know. Assignment 4 here, and you simply attach and submit. Okay? I hope that helps you wrap up the final assignment other than the class evaluation. Thank you very much.